Since PowerShell is powered by .NET, you have access to the entire set of objects and classes that are available inside the .NET framework and whatever assemblies you choose to load. Now, by default, a variable's data type is inferred by its assignment. So if I assign a string of A, B, C, D to a variable, PowerShell is going to know that that's a string. If I assign the value 12, it's going to infer that to be an integer. But it's possible to declare your variables through the assignment with an explicit syntax that says this number, even though it looks like an integer, is actually a floating point double. And that's done by including the type name in front of the value enclosed with square brackets. You can also create a number of objects from strings when the base type contains a parse method. And there are a lot of .NET types, simple types that contain parse methods, and I'll show you how to do this in just a second. It's very handy. And then finally, we can always find out what type we're working with by using the .NET getType method, which is part of the .NET base object. All right, so let's jump over to PowerShell and play around with some of these concepts. Okay, so let's get started by examining the type inference around a number and then the explicit setting of a data type. So we'll just start off by creating a variable, we'll call it n, and give it the value 3. Okay, and now if I test n with getType, and I'm just going to get the type's name, we can see that this is an int 32. But maybe I know that I'm going to be doing some math and I've got some fractions involved, some decimal places. So instead of declaring n as 3, I could explicitly say that n is a double. And now when I test its type, it's going to tell me that it's a double. Casting numbers is kind of fun, and it's pretty easy. Sometimes you'll be doing a mathematical operation with some inputs. Maybe they come from a comma delimited file and they're strings, and you want to tell PowerShell to treat everything in the mathematical operation as, say, an integer, as a whole number. So let's simulate that. I'm going to create a new variable called n1, and this time I'm going to put 3 in quotes. So n1 is going to be a string. And then I'm going to create n2, and we'll say that this is equal to 2, also in quotes. And now what we're going to do is we're going to use the n variable, and we'll say that we're going to take these values and treat them as ints when we say n1 divided by n2. Now notice that I didn't have to say int n1 divided by int n2. Certainly allowable, but this is a handy little shorthand to cast an entire expression, or rather the inputs into an entire expression, into a particular data type. Now, as I said, there are a lot of .NET objects that have parse as a method. And if you're using any of these, you can just cast a string and get the resulting data type. So a good example of this is the system URI class, and what I'm going to do is I'm going to just say create a new URL variable, and this is going to be a system. One great thing about IntelliSense is I know that if I don't get anything, it must be that I typed it in wrong. This is going to be a URI, and if I say that this is going to be HTTP www.google.com, I can then see that the URL, just based on IntelliSense, is in fact a URI, and I can get its host or any other of the pieces that I'm interested in. Now, of course, although there are many .NET classes that have a parse method, most of them don't. And so if you want to create a .NET object, you need to use the new object commandlet. And what it does is it creates a new object given a type name. And this works both with .NET objects but also with COM objects. A new object is fairly straightforward to use. The primary parameters of this function, or rather this commandlet, are the argument list. This is an object array of the inputs into the constructor. So what PowerShell does is it just picks that apart and calls the matching constructor if there is one, otherwise it throws an error, and it passes those values in to give you an initialized object based on whatever the inputs were. And then you can also specify the property parameter, and property takes a dictionary of name-value pairs to initialize the properties of an object. So instead of having to create an object and then write a bunch of code one line at a time to set a dozen property values, you can create an object, call its constructor, and populate a whole bunch of properties all in one go. Let's take a look at this in action. Alright, so the first demonstration I'm going to do is the creation of a COM object. Now, usually when I am developing a course, I like to come up with all of my own samples, and I certainly don't like to lift things whole cloth from any of the documentation that Microsoft puts out. But in the case of the new object keyword and the examples, there was one that was so good I just didn't really feel like I could top it. And so this comes from the help file, and I just want to give credit where credit is due. Alright, so what we're going to do is we're going to create a new variable. If I can get it to actually take my input. There we go. I'm going to create a new variable called Internet Explorer, and this is going to be a new object, and I'm going to use the COM object parameter to specify that this is a COM object. And the name of the COM object for Internet Explorer is Internet Explorer.application. Now this doesn't have a constructor, so I'm not going to pass an argument list into it, but I am going to populate some properties. All right, so we're going to use the property argument here, and like I said, this takes a dictionary or hash table of name value pairs, and so we're going to tell it where to navigate. And that's the navigate to property. And it's going to be equal to, since this comes from Microsoft, I suppose instead of using google.com as an example, I should use microsoft.com as an example in this case. And then after we set the navigate to property, we're going to say that visible is equal to true. All right. So my syntax is looking good, I think. Right? New object, Internet Explorer application. And we're going to navigate to www.microsoft.com and then show Internet Explorer. So let's hit enter and cross our fingers. Oh, and check it out. Here we are on the Microsoft homepage. All right, so for the next example, what I'm going to do is show you the creation of a URI using new object instead of the parse keyword. So the previous example I did of this was URI is equal to, and I just used system.uri, and I said this was www.google.com. Right, and then we saw that we could get the various elements of the URI. Now the system URI class has a constructor in addition to a parse method, and so let's use that instead. So this time we'll say URI is equal to new object, and this time we're going to say that the argument list is equal to the same thing that I used up here. Except this time let's add some stuff to the query string just so you know there's nothing up my sleeve. I will say foo equals bar and run this. And see I left off the type name, which was a mistake. Alright, so let's break out of there and do this again. Alright, so new object needs a type name, and that type name is going to be system.uri. All right, so let me scroll the whole thing into view so you can see it. And so now URI is still a URI. If I get the path in query, you can see that it's actually the new one that I just created as opposed to the old one that I created up here. Now, it's worth pointing out that there's a lot of stuff in the .NET framework that you can use from PowerShell that does not necessarily require you to actually create an object. A lot of the .NET classes contain what are called static methods, and a static method is a function of a .NET class that you can call without having to create an object. So new object isn't required, and you don't need an object instance. And the syntax for this is very simple. You take the type enclosed in square brackets and then use : followed by the method and the arguments list. All right, so let's take a look at a couple of static methods in PowerShell. All right, so let's start off with one that is easily the static method that I use the most often, and this is the now property of the datetime object. So remember, we start off by specifying the type. And datetime is part of the system namespace. This is more properly system.datetime, all right? But I don't need to actually use system here. And then I can say : and you can see that IntelliSense pops up all of the static properties and methods. And so I can say today and find out that today is November 28th, 2012. All right. The other one that I use really a lot is string format. And so once again, we can say string format, and string format takes in a mask of values. So this would be the first token, and this would be the second token. And then whoops, I said the second token, but it starts from 1. And then we would say maybe pass in sky and blue. And we get sky is blue as the output. Now the format command is the format method is extremely useful. It also takes masks that can format numbers in particular ways, that can format dates in particular ways, and that can format things using custom masks. As great as the .NET framework is, there's going to be times when there's not a class that does exactly what you want. There's not a static method that does exactly what you want. And so in those cases, you can resort to custom objects. Now, PowerShell does not have the concept of classes. In other words, you can't just create a class. So what you have to do is start off with a new object. If you were going to create a completely custom object, then you would start with new object of type system object or of type PS object, which is just a wrapper around the system object. And then once you've got that object, you would call add member, which is a command that you can use to add things onto existing objects. And so you can add properties and you can add methods. Add member can be used to extend any object. So it's actually probably more common to extend existing objects than it is to just start from scratch with system object and create something out of whole cloth. Whenever you use add member, what it does is it creates a PS object with a wrapper around the original type. So it's not actually changing the original definition. It's just wrapping it so that you can stick additional things onto it as well as access the contents of the original type. In some cases, especially with strings, you'll need to use the pass-through parameter on add member in order to preserve the original when you create a new one. And we'll look at that in just a second when I demonstrate how new object and add member can work together. Now there are many types of members that are available to you. You can test a given object or a given variable with getMember to see what all the members are that are available to that particular variable. But if you're going to extend an object in script with PowerShell, then the members that you can actually create are alias property, which just takes an existing property and aliases it under a new name. Note property, which creates a static property that basically just annotates an existing variable with some additional information in a read-only fashion. Script property, which creates a property which is evaluated by script. And if you're a .NET developer, you'll be glad to know that a script property can have a get block as well as a set block. But if you don't apply get and set, a script property is a get read-only. And then finally, we have a script method, which runs some script and returns a value based on some inputs. All right, so this is a really tricky concept. It takes most people a little while to get their head around it. And so we're going to run through some demonstrations now. Let's jump over to the PowerShell editor. All right, so let's start off by just taking a simple string and extending it. Get rid of the untitled 3ps1 here. And so what we'll do is we'll create a string, and we'll just call it text and give it some text as its value. And what we're going to do is extend this to include a note property. And so I'm going to say that text is equal to, and there are two ways that I could use add member. I could say add member and pass in the input object as a parameter. But the more common syntax that you'll see is using a pipe operation, which is exactly the same. So we're going to pipe text right into add member. And so what we're going to say is we've got a new member type, and this is going to be a note property. And you can see in the IntelliSense there that there's a whole bunch of different types of members that we could create. So I'm really barely scratching the surface of this concept here. But I am touching on the most common scenarios that I'm aware of. All right, so we're going to give this note property a value, or rather a name first, and it's going to be called original value. And then the value of this is going to be, we're going to take this text, and I'll say toString. And then finally, I'm going to pass this through. All right, so then we'll just say text dot original value, and we'll go ahead and run this, see what happens. And I didn't get anything back because I misspelled the property. And PowerShell does not bother to throw an error. If you attempt to access a member of something that's not there, it just returns an empty value. So let's fix that up. There, that looks much better, and run this again. And you can see that the output that I got is some text. Now there's a big time gotcha here, and I'm going to be using a string as the basis of the next demonstration. But strings are special in .NET in that they are immutable. Anytime I assign a value to a string or do something to a string, I actually get a new object that's a string. And so here's the gotcha if you actually tried to follow this along into a real production scenario with a string that you were actually attempting to do something like an extension method on. If I then came up here after the call here to original value, and I said text is equal to ABCD, and then I try to test for the original value, and we'll put little dash line in here to make this easier to read. All right, so let's run this, and you can see that I get some text, but then nothing after that. In fact, as soon as I did this assignment, I got a new object. We can prove this really easily. Right here, instead of putting out the original value, I'm just going to call get member, which I talked about just a second ago on the slide. So we're just going to pipe text into get member, and then down here, instead of doing the original value again, we'll pipe the text into get member a second time. And now let's run this, and we'll hide the script pane just to make this a little easier to read, and scroll on up to the first one. All right, so here's the first one, and you can see that when we did get member, thank you for snapping down. Let's scroll back up. You can see that the node property actually exists and that its value is some text. And if we come down to the second one, you can see that the original value has now disappeared. All right, so just be careful and be aware that strings are a little different. So if I actually wanted to create a string that held text and had a lot of methods, but I could change the string around, then what I actually would do is I would start with a new object and then extend it with properties and methods that did the thing that I wanted to do. But for the sake of time, we're not doing that here today. All right, so node properties are great, but script properties and script methods are a lot more useful in my experience. And so what I'm going to do now is do kind of a classic extension method example for a string. I'm going to add a property to a string that can tell me how many words there are in the string. All right, and so that's going to require me to have some script to actually execute. And so I'm going to create a variable called script property, and instead of putting some text in it, I'm going to put some script in it. And I can do that by surrounding it with curly braces. Now when we're working with a script property or a script method, we refer to the object that the method or property belongs to with the this automatic variable, as opposed to the $_ underscore that you have seen in a lot of the pipeline operations. So what we're going to say is that we're going to take this and we're going to split it. I know that this is a string because that's what I'm going to attach it to, but PowerShell ICE doesn't know, so I'm not going to get any IntelliSense for this. And the split method of the string object, it's got a couple of overloads on it, but one of the overloads is a series of characters. And so I'm going to create a new array, and we're going to look for an empty string and a period and a question mark. And anytime we encounter one of these characters, we're going to split that string. And I also don't want to get anything that's empty, and so this will take a system string split options, and this is an enumeration, but we use it just like a static method. So I just say : and I'm going to say remove empty entries, and then finally what I want to return is the length. Right? So string split creates an array of elements. I'm not really interested in having the array, but I do want to know its length. Right? And then, well, I already had that closed off. All right, so here we have a script. All right, so now we need some text. And so we'll say text is equal to, I don't know, a quick brown fox. All right, so when I extend the string, as you saw in the previous example, I'm going to get a new variable, and I need to pass that through. So I'm going to say that the text is going to be equal to the text piped into add member, and the member type this time is going to be a script property. And then the name is going to be word count. And the value for this property is going to be that script property. Oops. So the value is going to be that script property that I created, that block up there. And then, because this is a string, I need to remember to call pass-through in order to preserve the value. And so now, I can say text.wordCount, and it tells me that the string text contains 4 words, which are, of course, the quick, brown, and fox.